Let me continue with the examples. Now in example number 5. Now it's example number 4. Okay, differentiate the function of, let's have another function of t, where t to the fourth minus 1 over t to the fourth plus 1, or t to the fourth plus 1 in the numerator and t to the fourth minus 1 in the denominator is inside the square root symbol. Okay, so we have a radical. We can use rational exponent to write g of t. T to the fourth plus 1 over t to the fourth minus 1 is raised to 1/2. So to differentiate, we can use the general power rule, okay, to get g prime of t. So power rule is 1/2, that's the exponent, times the base, t to the fourth plus 1 over t to the fourth minus 1, raised to 1/2 minus 1. Okay, times the derivative of the base, t to the fourth plus 1 over t to the fourth minus 1. To get the derivative of the base, we have to use the quotient rule because it's the base is a quotient of t to the fourth plus 1 and t to the fourth minus 1. Let's continue simplifying. So 1/2 times t to the fourth plus 1 over t to the fourth minus 1 is now raised to negative 1/2. Now the derivative of the base using quotient rule, okay, this is u and this is v. Okay, this is the last time and that I'm gonna recall the quotient rule. The derivative of u over v is equal to v du minus u dv all over v squared. Alright, so it's v first, t to the fourth minus 1, times du. Du is the derivative of the numerator with respect to t. So the derivative of t to the fourth using power rule is 4t cubed. Okay, plus the derivative of 1, which is just equal to 0. Minus u, where u is t to the fourth plus 1, times dv, where dv is the derivative of t to the fourth minus 1. So it's 4t cubed also, all over b squared. b squared is t to the fourth minus 1 squared. Okay, we're done with the differentiation process. We'll just have to simplify the final answer. To make the exponent, this exponent, negative 1/2 positive, we'll just get the reciprocal of t to the fourth plus 1 and t to the over t to the fourth minus 1. So the reciprocal of that is t to the fourth minus 1 over t to the fourth plus 1. Now doing that, we can now have the exponent as a positive number, positive 1/2. Okay, now distributing 4 inside the next grouping symbols. So distribute 4t cubed inside the parentheses. There. Okay, we'll have 4t cubed times t to the fourth is 4t to the seventh. Minus 4t cubed times 1 is 4t cubed. Minus 4t cubed times t to the fourth is 4t to the seventh plus 4t cubed. All over the same denominator, t to the fourth minus 1 squared. Okay, combining like terms. So it's 1/2. Remember that in this expression, t to the fourth minus 1 and t to the fourth plus 1 are both raised to 1/2. So we can just have times t to the fourth minus 1 raised to 1/2 over t to the fourth plus 1 raised to 1/2 also. Okay. Combining like terms in the next grouping symbol, 4t to the seventh minus 4t to the seventh is 0. So what remains there is negative 4t cubed minus 4t cubed. So over t to the fourth minus 1 squared. So we can combine this and this. Okay. So combining those two, we'll have 1/2. That's actually t to the fourth minus 1 raised to 1/2 divided by t to the fourth minus 1 squared. Okay, we are dividing expressions with the same basis. And then we still have, of course, don't forget, we still have t to the fourth plus 1 raised to 1/2 in the denominator. Okay, times the numerator, negative 4 t cubed minus 4t cubed, it's minus 8t cubed. Okay, now dividing the constants for 8 and 2, we'll have negative 4 as a constant. Now, g prime of t is equal to, the constant now is negative 4. I'll write negative 4 first, and then negative 4 we have t cubed also. And then dividing t to the fourth minus 1 raised to 1/2 by t to the fourth minus 1 raised to 2. So what we'll do is copy the base and subtract the exponents, right? So we'll have 3/2 as the exponent in the denominator now. So 1/2 minus 2 is negative 3/2, which happens to be in the denominator. Okay. So that's t to the fourth minus 1 raised to 1/2 minus 2, right? And then over the denominator, t to the fourth plus 1 raised to 1/2. Okay, just rewriting your final answer, negative 4t cubed times t to the fourth minus 1 raised to negative 3/2. Okay, 1/2 minus 2 is negative 3/2 over t to the fourth plus 1 raised to 1/2. Okay, because we don't want a negative exponent in our final answer, t to the fourth minus 1 raised to negative 3/2 must be written in the denominator. So we'll get a negative 4t cubed over t to the fourth plus 1 raised to 1/2 and t to the fourth minus 1 raised to 3/2. Okay, we need to write this using rational exponents. No, using radicals, because the given function is in the form of a radical. You must be good in algebra here. So you recall that x raised to 1/2 is actually square root of x, and then x raised to 3/2 is actually square root of x cubed. When simplified is x square root of x. Okay, so this is like x raised to 1/2, and this is like x raised to 3/2. Okay, and x raised to 3/2 when simplified in radical form is x square root of x. So just follow the final answer. It's a negative 4t cubed over t to the fourth plus 1 raised to 1/2 is square root of t to the fourth plus 1. Okay, so square root of t to the fourth plus 1. And then t to the fourth minus 3/2 is t to the fourth minus 1 raised to 3/2 is t to the fourth minus 1 times square root of t to the fourth minus 1. So just like this form, there will be one t to the fourth minus 1 outside of the squared symbol, and then the other t to the fourth minus 1 must be inside the group, the radical sign or the squared symbol. This is the final answer in simplified form, in simplified radical form. This is the derivative of g of t. You see the differentiation process actually stopped here, this line, and then from then on we just simplified the final answer using algebra. The next example can be answered using product rule. Okay, I hope by now you know how to identify what formula to use to differentiate the function. So this is a combination of, to answer this, you need the combination of product rule and chain rule, okay, or the product rule and the generalized power rule, because this is a product of x plus 2 raised to the 5th power and x to the 4th plus 3 cubed. So we need to use the product rule. Okay, this is u and this is v. Now we recall the product rule. The derivative of the product of u and v is equal to u dv plus v du. Okay, where dv is the derivative of v with respect to the independent variable, and du is the derivative of u with respect to the independent variable. In this example, the independent variable is x. Okay, so the derivative of f of x with respect to x with respect to x is equal to u times dv plus v times du. Okay, so u is equal to x squared plus 2 to the fifth times the derivative of v, and v is x to the fourth plus 3 cubed, plus v, where v is x to the fourth plus 3 cubed, times the derivative of u, where u is x squared plus 2 to the fifth. Okay, we get du and dv by using the generalized power rule. Let's continue with the differentiation. X squared plus 2 to the fifth. Using the generalized power rule for the derivative of x to the fourth plus 3 cubed. So it's still the power rule, but we just have to multiply the power rule by the derivative of the base. So it's 3 times x to the fourth plus 3 raised to 2, because 3 minus 1 is 2, times the derivative of the base is x to the fourth plus 3. Okay, plus, we now copy the second term, x to the fourth plus 3 cubed, times the derivative of x squared plus 2 to the fifth using the generalized power rule. So it's 5, that's the exponent, times the base, raised to 5 minus 1, it's 4, times the derivative of the base is x squared plus 2. Okay, we're not done yet with the differentiation when we have d in our answer. Okay, so copying again, x squared plus 2 to the fifth, okay, times 3 x to the fourth plus 3 squared, times the derivative of x to the fourth plus 3 with respect to x using power rule. For the derivative of x to the fourth, it's 4x cubed, plus the derivative of 3 is 0, so we don't need to write that anymore. The next term is x to the fourth plus 3 cubed times 5 times x squared plus 2 to the fourth, times the derivative of x squared plus 2 using power rule. For the derivative of x squared, it's 2x plus the derivative of 2, which is just equal to 0. Okay, let me just rewrite the answer, multiplying the constants in the first term, 3 and 4. So it's 12, and then x cubed first, okay, times x squared plus 2 to the fifth. I'm just copying everything, rewriting the answer, x to the fourth plus 3 squared. That's all of the first term. In the second term, we have 5 and 2 as constants, plus 10x. And then copying every factor, x to the fourth plus 3 cubed, x squared plus 2 to the fourth. Okay? Now, we'll see, we'll have to look for the common factors. We only have 2 terms, right? This is the first term, this is the second term. So between the 2 terms, we'll have to look for the common factors. For the constants are 12 and 10. Common factor between 12 and 10 is 2, right? So let's factor out 2. And then for x cubed and x, the common factor is just x. So let's factor out x from the 2 terms. And then for the next factor, x squared plus 2 to the fifth and x squared plus 2 to the fourth, the common factor is, of course, x squared plus 2 to the fourth. So factoring x squared plus 2 to the fourth. And for the factor x to the fourth plus 3 squared in the first term, x to the fourth plus 3 cubed. Common factor is x to the fourth plus 3 squared. So factor out x to the fourth plus 3 squared. Okay, this is our common factor. We have to factor this expression from both terms. Okay, upon factoring from both terms, we will be left with, okay, in the first term, factoring 2x times x squared plus 2 to the fourth times x to the fourth plus 3 squared. So here, from 12x cubed, upon factoring 2x, we'll have 6x squared. 6x squared. And then from here, factoring x squared plus 2 to the fourth, we'll just be left with x squared plus x squared plus 2 to the 1, right? Or just simply x squared plus 2. And then for this, factoring x to the fourth plus 3 squared, we'll just be left with 1. Okay, so we don't need to write that anymore. Plus in the second term, for 10x, factoring 2x from 10x, we'll have 5. And then from x to the fourth plus 3 cubed, factoring x to the fourth plus 3 squared, factoring this, we'll have x to the fourth plus 3 raised to 1. And then from this factor, factoring x squared plus 2 to the fourth, we'll just be left with 1, right? So this is everything. Inside the brackets, we'll remove the grouping symbols by distribution. So just distribute 6x squared and 5 inside the parentheses. And we'll get, so we'll just copy the first, so it's 2x times okay, we do that again. 2x times x squared plus 2 to the fourth times x to the fourth plus 3 squared. Okay, now removing the grouping symbols. We'll have 6x squared times x squared is 6x to the fourth. Plus 6x squared times 2 is 12x squared. Okay, 5 distributed inside x to the fourth plus 3 will have 5 x to the fourth plus 15. And then combining like terms, these two are like terms, we'll have the final answer. Okay, the final answer 2x times x squared plus 2 to the fourth times x to the fourth plus 3 squared times 6x to the fourth plus 5x to the fourth is 11x to the fourth. Okay. And then plus 12x, I'm just copying the other two terms. 12x squared plus 15. Okay, this is our answer in factored form. This is the derivative of f of x. More examples in the next video.